Hi, let us try to prove the relation between beta and gamma function. So the relation is this: beta mn equals to gamma m times gamma n over gamma m plus n. Okay, so to prove this result, we are going to use the formula of beta function. And here you can see the three formulas of beta function. One is the basic formula, another one is given in terms of trigonometric, and another one is given in terms of improper integral. So this is the formula we are going to make use to prove the relation between beta and gamma. And also let us look at the formulas of gamma function. This is the basic formula of gamma function, and if we replace this x with x squared, and the formula would be this. So I'm going to use this formula to prove the relation. Okay, so let us look at the relation. So we need to prove this result. So instead of proving it, so I'd like to prove this one. That's gamma m times gamma n, that equals beta of m comma n gamma of m plus n. This is what we are going to prove. Okay, so to prove this, let us start with the formula of gamma m. So gamma m, I would write it like integral 0 to infinite. This is e power negative x square and x to the power of 2n minus 1 times dx. And whereas gamma n we would write in terms of, okay, here I should write 2 times, and we will write in terms of y, that is 2 times y equals 0 to infinite e power minus y square y to the power of 2n minus 1, this is m, 2n minus 1 into dy. So let us try to take their product. So when we take the product of gamma m into gamma n, so that is gamma m times gamma n, that is exactly 2 times 0 to infinite e power minus x square into x to the power of 2m minus 1 into dx, and this is 2 times integral 0 to infinite y to the power of 2n minus 1 into e power minus y square into dy. So here you can see that the limits are from x equal to 0 and this is y equal to 0. Now what we will do is, we will write this single integrals as double integrals. It means we are going to combine them. I mean, this is 2 times 2, you can see it as 4. Now you write x equals to 0 to infinite, and we'll write y equals to 0 to infinite, and this would be e power minus x square and e power minus y square times x to the power of 2n minus 1 and y to the power of 2n minus 1. So first you are integrating with y, so you write dy first, and then you are integrating with x, so you write dx. This will be equal to 4 times, I can directly write it like 0 to infinite e power minus of x square plus y square, and the other as it is, right? So now I'd like to do one thing. I would like to change to polar coordinates. Okay, so here we'll take polar coordinates. They are nothing but x equal to r cos theta and y equal to r sin theta. So I hope you can see what is dx times dy here, and Jacobian into dr d theta, where the Jacobian is r, so dr d theta. Okay, and if you observe that the limits here, x is from 0 to infinite and y is from 0 to infinite. So the region essentially represents the first quadrant. Okay, and what are the limits of the first quadrant with respect to the polar coordinates? Theta varies from 0 to pi by 2. So you can say that 0 less than or equals to theta less than or equals to pi by 2, and the radius, it starts from 0, it keep on goes. So 0 less than or equals r strictly less than infinite. So these are the limits of integration. So these limits would change as the limits here. And also we know one more thing, x square plus y square. So what would be x square plus y square here? X square plus y square would be equal to r square. So altogether, if we substitute everything in this integral, so we will obtain 4 times integral theta from 0 to 2 pi, 0 to pi by 2, the limits, and y from 0, not y, r from 0 to infinite. This is e power minus r square. Why? Because this x square plus y square becomes r square, and this one is r cos theta whole power 2m minus 1 r sin theta whole power 2n minus 1 into r dr d theta. Now just we need to simplify this. So you have e power minus r square, and you can see that r to the power of total, you can see 2m minus 1 plus, and here there is one more, that is 2n minus 1, and here is 1r plus 1. Okay, and the rest what we have is cos theta whole power 2m minus 1 and sin theta whole power 2n minus 1 times d theta. Okay, so this would be equal to, now like the earlier, we are going to separate the integrals now. Earlier we combined the integrals, now we are going to separate the integrals, because I can see function of r and function of theta separately. So now let us separate it, and I am going to share this 4 also as 2 and 2. So this is theta equals 0 to pi by 2. So 0 to pi by 2. This is sin theta whole power 2n minus 1 and cos theta whole power 2m minus 1 times d theta. And this is exactly beta mn times, again 2 times r equals 0 to infinite, which is e power minus r square. This is r to the power of 2 times of m plus n minus 1 times dr. Okay, so if you observe that the first one is exactly beta mn, and the second one is exactly gamma of m plus n. Okay, so we actually started with gamma m times gamma n. Okay, so therefore we can conclude that from this, beta mn is equal to gamma m times gamma n over gamma m plus n. So I hope you understand. Thank you.